Hello everyone and welcome to the CP-31 Sheet solutions. Today we'll discuss the 1600 rated problem, array walk. So let's pull up the CP-31 sheet and it's the 28th problem on the sheet. So let's open it up and let's go ahead and read it. Okay, you're given an array consisting of n positive integers. Initially, you're standing at index 1 and have a score equal to a1. You can perform two kinds of moves. Move right, which means go from your correct index to index x plus 1 and add ax plus 1 to the score. This move can only be performed if x is less than 1 and if x is less than n. The second operation is move left. Go from your correct index to index x minus 1 and add ax minus 1 to your score. This can only be performed if x is greater than 1. Also, you can't perform two or more moves to the left in a row. You want to perform exactly k moves and there should be no more than z moves to the left amongst them. What is the max score you can achieve? Okay, so the elements of the array are given, k is given, z is at most 5. Okay, so pay attention, z is at most 5, so the moves to the left are at most 5. Okay, so let's write down the constraints. Obviously the expected complexity will be big O of n here, right? Expected time complexity is going to be big O of n or big O of n log n, right? Yeah, and z, note that z is less than equal to 5, right? Z is less than equal to min 5 and k, so z is less than equal to 5. Cool. Then yeah, let's take an example. For example, 540 541. Okay, so let's take this example and try to understand what the problem is asking. 540 15432. Okay, so in this problem we start at this position and we can make 4 moves, of which 0 moves are to the left. So obviously we'll make all the moves to the right and we add up all these numbers and we get 15, right, which is our answer. Now when z becomes 1, we have the option of making either no moves to the left or one move to the left. All right, so what happens when we make one move to the left? Basically, let's say we're going along and at this position we make one move to the left. All right, so we go one step back, then again we come here and again we go front, right? So 1 2 3 4, right? So sorry, we finally end over here. So total 4 moves and the sum will be 1 plus 5 plus 4 plus 5 plus 4, right? And this sum is equal to 19, right? So the answer is improved, so it's better to make this move back, right? And our answer is going to be improved, which is equal to 19. Okay, so how do we reason about this kind of solution, right? So first of all, we know that z, there is only 5 values of z, right? So that already gives us a hint only 5 values of z. It's a major hint, right? Only 5 values, right? From 0 to 5, so 6 values total. So from 0 to 5 z can range, right? So that means we can consider at most so we can consider for each z value what is the maximum and then take the max of all the possible z values and then take max of all of them. So basically we're brute forcing over z. Okay, we're brute forcing over z, brute force over z. That's essentially what we're doing. Cool. So how do we go ahead and approach this? So basically for each z value we're going to calculate the maximum and then finally we're going to take max of all these cases and print that as our answer, right? Okay, so what if the z value was fixed? Okay, what if the z value was fixed? So let's take the first example where z was equal to 0. Okay, z was equal to 0 and a1 a2 a3 a4 a5 a6 a7, right? If z is equal to 0, that means it's fixed that we need to take the first k plus 1 elements, right? We can move k times one step to the right. So obviously we have to take the first k plus 1 elements and that will be our answer, right? That will be our answer. So if z is equal to 0, our answer is simply equal to sum of first k plus 1 elements. Right? Okay, what if z is equal to 1? Fine, what if z is equal to 1? Then what happens is, let's say k was equal to 5, okay? So k was equal to 5, 1, 2, 3, 4, 5. Right? But at some point we turned around and went left. Right? At some point we turned around and went left. And so basically, let's say this was the point. So this happened. Right? So basically, these two sums are getting cancelled, right? We're not adding a5, a6, right? So what is going to happen is basically we have our base sum, right? Our base sum is going to be like left, which we got through pure right movements. And this base sum is going to be the sum of k plus 1 minus 2z elements. Okay, this sum is going to be for k plus 1 minus 2z elements. Observe why this is true. This is true because anyways, when we're moving, let's say k steps, right? And z are left, right? Z are left steps. So what's essentially going to happen is we are going to end up at what position? We're going to end up at the position k, right? So k steps minus 2z. So we're going to end up at this position k minus 2z, right? K minus 2z plus 1, because obviously we're starting at position 1, so that's why plus 1. So k minus 2z plus 1 is going to be the position we end up at. So obviously we need to sum all these numbers, right? Now based on where we took the left turn, right? Based on where we took the left turn, like for example, in this example, we took the left turn over here, right? So that means this value was added a3, and then a4 was also added again, right? Let's take another case. Imagine we took left turn over here. So this is the case we took left turn at a4. What if we took left turn at a3? Okay, what if we took left turn at a3? Then what would happen? 1, 2, this is the left turn, and then like this, right? So again, these base values will be summed, but then wherever we took the left turn, that is also going to be summed like a3 plus a2, okay? So the sum of base value plus wherever we took the left turn, so a3 plus a2, these two adjacent elements are getting added, okay? So let's try to say the same example, but z equals 2, right? Z equals 2, right? Let k equals 5 itself. Now what is going to happen is basically our base value is going to be k minus 2z plus 1, right? K minus 2z plus 1, that's equal to 5 minus 4 plus 1, right? And that's basically going to be 2, right? So these two are our base values. We go left here, and now we need to take two left turns, right? So we reached up to here. So either we can take a left turn like this, right? We can take a left turn like this, or we can take a left turn directly like this, right? And all the ways we will end up at a2 in the end, right? Basically what we're trying to say is we're going to end up at a2 finally. So basically we're summing this, and then every position where we took a possible left turn, we're going to include that we went front and back at that position, right? So we could have gone front and back here and ended up at a2. Another time we could have gotten front and back here, or we could have done some combination of this, like we could have gone like this. Eventually we will end up at a2, right? Okay, so basically what have we decided? We have decided that for each z, what have we learned? Observation from this. For each value of z, we are moving k steps, and z steps are to the left, then our final position will be equal to k minus 2 times z plus 1, okay? So that's why we can say that already we can have our base sum will be equal to the sum of all values from I equals 1 to I equals k minus 2z plus 1, right? So this is from the start position to the position where we ended up at finally, right? Now we need to consider the left turns, consider the positions of the left turns, of left turns, right? And we can add the fact that we took a left turn and then a right again, right? Note that we can't take two left. We can never have two left turns because the question clearly says that you cannot perform two or more moves to the left in a row. So that means we cannot have two direct left turns, right? So each left turn is going to be left plus right, like this, right? So each left turn is going to be a pair, left turn and right turn. That means which numbers will get added? If we took left turn at position I, then the positions I and position I minus 1 will be added to the answer, right? So the sum, total answer for particular Z, let's write down the equation for this. So it will be equal to sum from I equals 1 to k minus 2Z plus 1, right? K minus 2Z plus 1 of A of I plus the sum of the chosen I values where we are doing left turns. So A of I plus A of I minus 1, right? So this is going to be our sum for a given value of Z. Okay. Let's call this result or res. Okay. Now, obviously we need to choose which I we are going to use for left turns, right? And obviously we can choose the same I multiple times. So why not just take these? So we need to choose Z of them, right? We need to choose Z of them, right? So why not just take these and always choose the maximum one, right? Choose the one which has maximum value of this. Since we want to maximize the answer, always choose Z times for max of A of I plus A of I minus 1, right? And that's all we can say. That we can pretty simply we can say greedily we'll always take the maximum left turn possible. So we can just write this equation again. So I'll just simplify this to base sum plus Z times max value of AI plus AI minus 1 for basically I less than equal to K minus 2Z plus 2. Okay, plus 2 um because basically we are ending up at position like I showed you that we are going to end up at a particular position, right? We're going to end up at A2. So that means one way to end up at A2 is going to A3 and coming back to A2. That's why we need to consider A of I minus 1, right? So that's why we're going to consider A of I minus 1. So you can think about it like that, or you can think about it like as A of I and A of I plus 1, right? A of I and A of I plus 1. Then that way also it's very natural to think about. Okay. Yeah. So all we need to do is for each Z, for each Z, for each Z, simply calculate this value. Simply calculate this value. And then what we can do, we can say that our answer equals max of this result over all Z, right? All Z. Since Z is less than equal to 5, our overall time complexity is going to be big O of Z times N, right? Which is at most 5 times N. So overall time complexity is big O of N itself, right? And memory complexity, we obviously need to store the array. So memory complexity is also big O of N, right? That's about it for this question. It's just a simple greedy, right? Thinking about how many left steps are done, how many right steps are done. So that way we know that these many positions need to always be taken. And then if we have a left move, then we take two positions. So we'll always take the maximum two positions in each case, right? So let's have a look at the code, because even though the idea is easy, the implementation could get a bit tricky. It did get for me. I was having off by 1 errors. So yeah, please implement it carefully. Let's go through the implementation, okay? So here I'm taking in nkz, I'm taking in the array, and then z goes from 0 to the maximum possible z. Also, we need to ensure that z remains 2 times z remains less than k, right? Otherwise, it won't make sense. So 2 times z remains less than k, because we're saying we're moving z times to the left. So if that is more than k itself, then obviously we can't do that. Okay. Now here I'm just summing the first. So I'm calculating the base sum, right? I'm summing the first k minus 2z plus 1 elements, right? So this part, simple accumulate function. make sure to use long because the answer might exceed int, right? Now I'm going to have a max value which is going to store the maximum value of a of I plus a of I minus 1, right? Or if you do it zero indexed, so if you start at I equals 0 and go to, then we can say that it's a of I plus a of I plus 1. That way you can do it. Once we have found the max one, we can simply say that, okay, z times to the left we have to move. We'll always move this max one, right? Like left, right, left, right, left, right at this max position. So the result is equal to, is added by z times this max. Now for all z, we want to take the max. So we just take max of answer and the result for all z. And finally we can output the answer, right? So that's about it for this question. Time complexity is n times z and memory complexity is n, right? Z goes up to 5, so it's perfectly possible. It's almost big of n itself, right? Yeah, so that's it. If you had difficulty with this problem, definitely think about, more greedy ideas, like how many steps we're moving to the left and right. Like that observation was pretty constructive, or you could say math, basic observation on like greedy. So like that was the crux of the problem. And also obviously, whenever you're given like z less than equal to 5, you should know immediately like that's a hint. Usually numbers are not given as low as 5 unless you're trying to brute force something, right? So that was a hint that you're going to brute force on z, right? So yeah, that's all. Do upsolve it, right? Because implementation is tricky, and do make sure to code it yourself, right? That's about it for this one. Thank you for watching and see you in the next solution. Bye bye.